Have you ever been using an app, maybe a website, and it just suddenly slows right down? Or, worse, crashes? Probably because tons of people are hitting it at the same time. Or maybe you've heard stories about companies spending, well, a fortune on computing power they don't actually use most of the time. Kind of like paying for this huge stadium, just in case it sells out someday. Well, today we're doing a deep dive into a really powerful Kubernetes feature that's designed to fix exactly those problems. It's called the Horizontal Pod Autoscaler, or HPA for short. Our mission really is to unpack what HPA is, why it's so important, absolutely crucial even for modern apps, and how it actually works, behind the scenes. Think of this as your shortcut to understanding dynamic application scaling. We want you to get the knowledge quickly, but properly, and hopefully have a few aha moments along the way. Okay, so let's unpack this then. At its core, what is the HPA in Kubernetes?
Right. So fundamentally, the HPA is a Kubernetes resource. Its job is to automatically adjust the number of pod replicas. And pod replicas, yeah, just think of them as running copies of your application. It does this within things like deployments, replica sets, or stateful sets. Basically, the tools Kubernetes uses to manage applications that need to scale.
Okay, so it's like, imagine the HPA as a smart manager. It's constantly watching how busy your application is getting. So if loads of users suddenly show up and the existing pods start getting overloaded, what does it do? Is it always just about adding more pods?
Primarily, yes. It adds more pods pretty quickly to show the workload. The main goal is to prevent that overload from actually impacting users. But yeah, the nuance is how it decides. It uses real-time metrics, usually CPU or memory usage is the default. And then if traffic drops off later, it's smart enough to remove those extra pods to save resources, keeps things smooth, but also efficient.
Right, saves money.
Exactly. So a key thing here is its dynamic nature. It scales up or down based on those live metrics. And importantly, it's not just CPU or memory. It can use custom metrics too, like requests per second, which makes it super flexible.
That custom metrics part sounds really powerful. Does that add much complexity for the team setting it up, or are there times when it's just way better than just watching CPU?
It does add a bit of initial setup. Yeah, you need to configure how to get those metrics, but the payoff can be huge. Using something like queue length, for example, isn't just more complex, it's more proactive. You're scaling based on maybe a leading indicator of user experience, not just a symptom like high CPU, so you can potentially prevent problems before users even notice them.
Ah, okay, so it's about getting ahead of the curve.
Precisely. And the big win overall is the automation. It takes away the need for someone to manually scale things up or down. That's a massive time saver and frankly reduces the chance of human error.
This automation, it sounds like it's more than just convenience, right? It feels like it changes how teams operate fundamentally. What does getting rid of manual scaling really unlock? It's just about saving money? Or does it free people up to do, well, more interesting things?
Oh, absolutely. You've hit it right there. The cost savings are real and significant, don't get me wrong. But by automating this, fundamental task, engineers and developers are freed up. They're not constantly in reactive mode like, uh-oh, the app's slow, quick, add more server. They can actually focus on building new features, improving the core product, innovating. It enables a much more agile approach.
Turns an operational headache into something you can mostly set and forget.
Pretty much. And think about the real world impact, like those huge online sales events, Black Friday or something. A few seconds of lag there could mean, well, huge losses. HPA is working behind the scenes to prevent that kind of meltdown.
Makes sense.
Or maybe you have a microservice just handling API requests that vary wildly. Or a batch job that only needs lots of power sometimes. HPA handles all that variability.
Okay, so zooming out a bit then, how does this capability translate into, real advantages for the apps we use every day?
This is where it's interesting for everyone, I think. The core problem HPA solves is that application workloads, well, they fluctuate a lot. Sometimes it's sudden user spikes, sometimes it's just varying processing needs. HPA makes sure the application can handle that efficiently, seamlessly.
Yeah, the benefits are pretty clear when you list them out. First, obviously, handling those variable workloads. It adds or removes pods to match demand, keeping performance good during peaks and troughs. Second, resource efficiency. You mentioned cost saving. By scaling down when demand is low, HPA stops you from over-provisioning. That directly saves CPU, memory, and yeah, cloud costs.
Money. So performance and cost, those are big ones. What else? Reliability. Definitely. Improved reliability is key. By ensuring enough pods are running during peak times, it significantly cuts the risk of your app slowing down or, crashing. And the automation itself is a benefit, freeing up human operators for more complex tasks. Plus, that support for custom metrics we talked about adds flexibility. It can adapt to almost any kind of application need, not just CPU load.
Okay, those are compelling benefits. But I'm curious, are there any common, maybe, misunderstandings about HPA? What's something people sometimes get wrong or oversimplify?
Yeah, a common one is thinking HPA is some kind of magic billet for all performance issues. It's fantastic at scaling based on load, but it can't fix, say, really inefficient code or a bad application design.
Right. Garbage in, garbage out, scaled up.
Sort of, yeah. If your app uses 100% CPU because of a bug, like an infinite loop, HPA might just keep adding more and more pods trying to meet the demand, costing you a fortune without fixing the root cause.
Okay, so it's a tool, a powerful one, but needs a reasonably healthy application to work with.
Exactly. It's a crucial part of a well-run system, but not a substitute for good engineering practices. And just thinking about the alternative, if you don't use HPA, you're back to manual scaling, time-consuming, error-prone. During spikes, your app gets slow, users get frustrated, maybe leave. During quiet times, you're just burning money on idle resources.
That really puts it in perspective. A great real-world example of this working well, maybe think about an online streaming service. Let's say it's running on Kubernetes. During a big live event like a sports final, thousands, maybe millions of people start watching all at once. CPU usage probably goes through the roof. The HPA sees this spike instantly. It seamlessly adds more pods to handle the load. Result, smooth streaming for everyone, no buffering, no crashes.
Yeah, exactly.
Then, the event ends, traffic drops. HPA notices this too and intelligently scales things back down, keeps costs under control. It's really orchestrating things behind the scenes.
That's a perfect illustration.
Okay, so we've covered the what and the why, the concepts, the benefits. Now, maybe for the more technically minded listeners, let's pull back the curtain a bit. How does this smart manager actually work under the hood? What are the mechanics?
Okay. So the HPA is basically in a continuous loop. It monitors metrics for the pods it's responsible for, and then it adjusts the number of replicas based on the targets you've set. It works with those scalable resources we mentioned, like deployments, and it relies on getting metrics data, usually from the Kubernetes metrics server for basic stuff, or maybe other systems for custom metrics.
Right, so what's the workflow like, step by step?
It starts when you, the user, define the HPA resource itself. You create it for a specific workload, say a deployment running your web server. In that definition, you tell it what resource to scale the deployment, what metric to watch, maybe CPU utilization, what the target value is, like keep it around 70% average CPU, and crucially, the minimum and maximum number of pods.
Min and max, okay. Like guardrails?
Exactly. You might say minimum 2 pods, maximum 10 pods. It won't go below or above that, no matter what the metrics say. Prevents things from scaling down to 0 or scaling up indefinitely if something goes wrong.
Got it. So step 1, define the rules. What's next?
Step 2, collect metrics. The HPA controller actively queries for the current metric values. For CPU and memory, it usually talks to the metrics server. If you're using custom metrics, maybe requests per second, it'll talk to whatever system provides that, like Prometheus via an adapter. It then calculates the average value across all the pods it's currently managing for that workload.
Okay, so it gets an average. If our web server pods are collectively averaging, say, 90% CPU and our target is 70%.
Then it moves to step 3, the scaling decision. It compares that observed average, 90% to the target, 70%. It does a calculation, basically figuring out how many pods would be needed to bring that average down to the target. It's a ratio calculation, more or less. If the average is too high, it decides to scale up. If it's too low, say 30%, it decides to scale down, always respecting those min-max boundaries.
So in our 90% VADIA 70% example, it calculates it needs more pods to spread the load. Maybe it decides it needs, say, 2 more.
Right. Let's say it calculates it needs to go from the current number, maybe 2 pods, up to 4 pods to hit that 70% target, which brings us to step 4. Adjust the replicas. Now, the HPA itself doesn't directly create or delete pods. That's not its job. Instead, it updates the definition of the target resource and the deployment in our case. It changes the replicas field in the deployment spec from 2 to 4.
Ah, okay. So it tells the deployment you should have 4 replicas now.
Exactly.
Yeah.
And then Kubernetes' own control loops, specifically the deployment controller, see that change. It then takes the action to create the 2 new pods needed to reach the desired state of 4.
Okay, that makes sense. It leverages the existing Kubernetes mechanisms, and this isn't just a one-shot deal, right?
No, absolutely not. Step 5 is continuous monitoring and adjustment. This whole cycle, check metrics, calculate, decide, adjust, spec, repeats periodically. The default is often around every 15 seconds, though it's configurable. It's constantly checking and making small adjustments as needed.
So it keeps things stable.
Right. It also usually includes stabilization features. So if the metrics are jumping up and down really fast, it won't necessarily scale up and down aggressively every 15 seconds. It looks at trends over a slightly longer window to avoid flapping.
Flapping,
Or-
okay? Rapid scaling back and forth.
Yeah, which can be disruptive.
Yeah.
So after our traffic spike ends, maybe the average CPU drops to 30%. On the next check, the HPA calculates it can scale down, maybe back to the minimum of 2 pods, and updates the deployment again, saving resources.
It really is like an automatic thermostat, isn't it? Constantly checking the temperature, the metric, and adjusting the heating, cooling, the number of pods
Yeah.
to stay at the set point, the target.
That's a great analogy. Yeah.
And the key components making this happen are, as you mentioned, the metric server for the basic CPU memory data.
Yep, that's crucial for out-of-the-box HPA.
Then custom metrics, which are optional but add that flexibility, often needing something like Prometheus.
Right, for application-specific scaling.
The scaling parameters themselves, those targets, min-max counts, stabilization windows, those are your controls.
Tuning knobs, yeah.
And finally, the target resource, like the deployment or stateful set, which actually manages the pods being scaled.
That's a complete picture, pretty much.
Okay, so wrapping things up a bit, we've really untacked the Kubernetes Horizontal Pod Autoscaler. We've seen how it acts like this intelligent, automated system. It handles dynamic application scaling, reacting to real-time demand to keep apps running smoothly and cost-effectively.
Yeah, it's like having that vigilant manager watching over your app's capacity 24/7 without needing the coffee breaks.
Understanding HPA, even at this level, gives you, the listener, I think, a really powerful insight into how modern, resilient applications are built and managed today. Whether you're, prepping for a meeting, trying to get up to speed in the tech field, or maybe you're just really curious, knowing about this helps appreciate the efficiency and reliability we often take for granted in the digital world.
It's a foundational piece of cloud-native infrastructure now.
Definitely. So here's a final thought to maybe noodle on. We've seen how dynamic optimization, this auto-scaling, transforms technical systems facing fluctuating demand. But imagine applying that core principle, adapting resources automatically based on real-time needs elsewhere. What other areas, beyond software and business, logistics, maybe even daily life, where else could an auto-scaling approach bring similar benefits of efficiency, responsiveness, maybe even resilience? It's kind of a fascinating concept to think about. How we manage resources in response to demand makes you think about efficiency in a whole new light.